For lesson 3 of our fractions unit, we'll be looking at adding and subtracting fractions. This is mostly review, but it may be a little bit different than the way you learned it the first time around. So kind of keep an open mind and see if this helps you to get a better understanding of the process of adding and subtracting fractions. So we're going to start with what's called the main rule of addition, okay? You can only add the same things. When you add the same things, you get the same things. What does this mean? Well, if I say there's 2 cats plus 3 cats, those two things are the same. They're both cats. 2 cats and 3 cats is just 5 cats. But if I say 2 cats plus 3 dogs, you can't answer that without making some things change around, like maybe calling them both types of animals or types of pets. But you can't say 5 cat dogs. That doesn't make sense because it's not what you meant. All right? So this actually works exactly the same way for adding and subtracting fractions. So if the denominators are not the same, remember that means the bottom number, you want to find the LCM to convert the denominators, meaning make equivalent fractions, okay? And then you can go ahead and add the numerators, keep the denominators the same. If you didn't use the least common multiple, then you may need to factor, like we did in lesson 1, and simplify. So what's the main thing I said here? Well, what we're trying to do is make the bottom numbers the same. And once they are the same, they stay the same. Just like the thing with the cats and the cats. So, for example, if I have 2 17ths and 9 17ths, those are the same things. They're both 17ths. So I can just go ahead and add them to get 11 total 17ths. Okay? Like in number 5, 1 2/3 plus 2/3. So because I have the thirds, they're the same things. But we just want to make sure that this mixed number gets turned into a fraction first so that we can actually do some math with it. So remember, 3 times 1, and then add to the top. So 3 plus 2, so that's going to be 5/3 plus 2/3. 5/3, 2/3, so those are both thirds, so we can add them to get 7/3. And if you want to convert it back, 3 goes into 7 twice, which is 6, so there's 1 left over. Okay? 2 sevenths and 1/5. Sevenths and fifths are not the same things, but we could make them into the same things, and then we'd be able to add them. So we can do 2 sevenths and 1/5. I'm just going to multiply this first one by 5/5. Remember, that's equal to 1. And I'm going to multiply the second fraction by 7/7. Why? Because that's going to give me in both fractions a denominator, a bottom number of 35. So now they are the same things. 2 times 5 is 10. 1 times 7 is 7. And we're going to add these up. So we would get 17/35. So then for number 6, this one's a little harder because we've got the mixed numbers. So let's change it so that it's just a fraction. Okay? So remember, 8 times 2 is 16. Add the 7. So you're going to get 23/8 plus 9/5. Now, these are not the same things because we have eighths and fifths. So let's make them the same, okay? So another way that I could write this, instead of doing it vertically like I did in this other one, I could actually space it out a little like this. And then I'll just show it in a different color. So I'm going to use 5 for this one, 5 over 5, because that's 1. And I'm going to use 8 over 8 over here. Why? Because that makes it so that the bottoms are both going to be 40. And once they're the same, we can add them. So let's see. 23 times 5. If you're not sure, you can write it off to the side. So 23 times 5 is going to be 115. And then 8 times 5 is 40. And again, we've got 40 on this new fraction as well. 9 times 8 is 72. And then we can just add them up. So you can write it off to the side if you need to, like this. Line it up. You get 187 over 40. If we wanted to convert it, we'd have to figure out how many times 40 goes into 187. So I know that 4 times 4 is 16. So if we do 4 times, that'd be 160. 187 minus 160 would be 27/40. So 4 and 27/40. Okay, subtraction is actually the same thing. So subtraction is what's called the inverse of addition. Another word for that is opposite, okay? So the main rule of addition from up above applies to subtraction. It's the same rule. So think about it. 4 oranges minus 3 oranges. Well, they're both oranges, so 1 orange. But if I'm like, okay, 12 lemons minus 5 apples, you can't really directly do that. You'd have to change them both into fruits and say you just had 12 of one kind of fruit minus 5 of some other kind of fruit, and you'd get a total amount of fruits. But you wouldn't necessarily know apples and lemons. You can't subtract those directly because they're not the same things like our main rule says. Okay, so same exact rules here. If the denominators or the bottom numbers are not the same, find the LCM to convert the denominators. Now subtract the numerators. Keep the denominator the same. And if you did not use the least common multiple, you may need to factor and simplify. Okay, so let's see a couple of examples here, okay? All right. So our first question actually has a mixed number in it, so we're going to want to change that. So remember, multiply and then add. So 5 times 1 is 5, plus 2 is 7, so it makes 7/5 minus 4/5. They are the same things, so we can just go ahead and subtract. So 3/5. Number 11. So 14 and 4, they're not the same things. So we have to figure out how to make them into the same things. I'm not sure if I can think of anything that 14 and 4 both go into. So I might just multiply 14 and 4 together and go from there. Okay? If you can think of something, then you could use that. So if I list out my 4s, 4, 8, 12, 16, 20, 24, 28. There you go. We could actually use 28. So if we use 28 as our least common multiple, we won't have to simplify later. So I'm going to write 5/14, and I'm going to write 1/4. Okay? And I'm going to change these both. We're trying to make 28s. So for the 14, I'm going to use 2. 14 times 2 is 28. And then on the top, I get 10. For the 1/4, I'm going to use 7 over 7. So we get 7/28. And remember, this was subtraction. So our final answer is going to be 3/28. Okay, next up, 4/6 minus 12/18. Actually, I think we could probably simplify the 12/18 if we wanted to. But let's keep using our method. If I change 4/6 so that it becomes out of 18, I think we'll be able to do this one. 6 goes into 18 3 times. So if I times by 3 on the top and the bottom, we'll just leave the 12/18 the same. We're going to get 12/18. So now this problem says 12/18 minus 12/18. So that's just 0. Okay, last one. This one's a little harder. It's got 2 mixed numbers. So multiply and then add. 8 times 2 is 16. Plus 5 is going to be 21/8. Minus, go ahead and multiply and then add. So 3 times 1 is 3 plus 1 is 4 thirds. Now we've got eighths and thirds. They don't match. They're not the same. So to do this problem, we have to do some converting. We have to make a common denominator. I'm thinking I'm just going to use 24. So it'll be, and I'll write this the other way. So I'm just going to space it out a little bit. Multiply by 3/3. Multiply by 8/8. And then we're going to get 63/24 minus 32/24. Keep that 24 on the bottom because we have 63/24 minus 32/24. So we're going to have some number of 24ths at the end. So 63 minus 32 is going to be 31. If we want to convert it, we can say 1 and 7/24 as our final answer. Okay? And for today, there is a challenge question here if you'd like to try it, but I am not going to count it as a question in our Edpuzzle because it's a challenge for that reason. So if you try it and you want to let me know that you tried it, you can always send me a Hangouts message.